In this example, we have parentheses and we have brackets. First, we have to do our operation, which we can do in the parentheses. We have m minus n, different terms, so we cannot do anything. We have m cube plus m cube, so we cannot do anything. So first, I will rewrite these two parentheses, m cube plus n cube, and next we will check what we can do in the brackets. Because we have m plus n in parentheses, we can not do anything here. We have different variables. For parentheses, we have m times. So every expression in parentheses we have to multiply by m. So in brackets we will have m times m, and we have m times n. We have positive variables, so it will be positive sign, m times n. And we have to copy n square, close brackets. So this is equal, and I will copy m minus n times m cube plus n cube. And now in the brackets we have m times m, so this is m square. And when we have the same variable, we copy variable and we just add exponents. When we don't have, it's always invisible 1. 1 plus 1 is 2. Next we have m times n, so we have to copy, and we have plus n square. This is equal. Next we have here multiplication between these parentheses, and inside brackets we cannot do anything, so we have multiplication between these parentheses and brackets. We can change brackets to parentheses. So, because we have multiplication between these three parentheses, we can first multiply first parenthesis times the second parenthesis, or second parenthesis times the third parenthesis. It doesn't matter which multiplication we do first. Because we have multiplication, we can choose how is convenient for us. Because we have here m minus n, in the third parenthesis we have m squared plus mn plus n squared. So I will first write the last parenthesis, and the second I will put at the end. So we have and now we have here formula for difference of two perfect cubes. If you don't see this, you can multiply every term from the first parenthesis by every term in the second parenthesis. And when you combine the like terms, you will have difference of two perfect cubes. So maybe I will do this to show you that for sure we have here difference of two perfect cubes. Let me copy these two parentheses. We have m minus n times m square plus mn plus n square. We have multiplication between these two parentheses. It means we have to multiply every term in the first parenthesis by every term in the second parenthesis. So we have m times m square first. So it means we have to multiply m times m square plus mn plus n square. And now we have negative n times m square plus mn plus n square. So this is equal. Now we have to multiply every expression in the every term in parentheses by m. So m times m, we have square of course, plus m times mn plus m times n square minus, and now we have negative sign before parentheses, so we have to change every sign inside parentheses to opposite. When we don't have sign, is positive here, so negative times positive will be negative, and we have n times m square, negative times positive, so will be negative, n times m n, negative times positive, so will be negative, n times n square. So this is equal the same base. So we copy the base and we add exponents. So when we don't have is invisible 1. So 1 plus 2 is 3. 1 times m plus times m squared is m cubed. Plus the same base, m and m, so we copy m and we add exponent, invisible ones. So we have 2 and n we have to copy. And we have m n squared minus, and now I will put in alphabetical order variables. We have m and n, so first will be m square n minus, and again the same, I will put m first and next n times n is x squared. We have invisible exponents 1, 1 plus 1 is 2, minus invisible exponent 1, so the base we copy and we add exponents. 1 plus 2 is 3, so this is equal. Now we can combine the like terms. We have m square n and negative m square n, so we can cancel out. This is 0. And we have n m square and negative m n square, so this we can cancel out. This is 0. So we have only m cube minus n cube. Like I said, this two parentheses give us difference of two perfect cubes formula. So instead of two parentheses, we have only this m cube minus n cube. So let me come back to our example. I did this multiplication already here, so now I can write instead of two parentheses only m cube minus n cube, and in the second parenthesis we have m cube plus n cube. We see that we have the same terms, m cube, n cube, only different sign. So we can use now formula for difference of two perfect squares when we have a minus b times a plus b. This is equal a squared minus b squared. In our example, a is equal m cube and b is equal n cube. So now we can substitute these two parentheses by this form only. So this is equal, a in our example is m cube and we have to take 2 second power minus, we copy and we have b cube, so n cube to second power. So this is equal power to power, so we have to copy the base and we have to multiply in exponents. 3 times 2 is 6. Negative sign we have to rewrite and again copy the base, power to power, so we have to multiply. 3 times 2 is 6. We have different terms, we cannot do here now anything. So this is my solution.